In the Quran, God asks, أَفَرَأَيْتُمُ الْمَاءَ الَّذِي تَشْرَبُونَ? Have you ever considered the water you drink? To answer yes to that question, let's consider water from a scientific and Quranic perspective. The Quran tells us that all living things are from water. وَجَعَلْنَا مِنَ الْمَاءِ كُلِّ شَيْءٍ حَيٍّ. Water is a requirement for life, and all life originated from water. Science tells us that water is critical for life on Earth because water acts as a solvent in which biochemical reactions take place. It aids in temperature regulation and plays a crucial role in the structure and function of cells. Water is special because it is a polar molecule. It has a partial positive charge on the hydrogen side and a partial negative charge on the oxygen side. This allows water to form hydrogen bonds, causing it to create a cohesive network and high surface tension. It also allows it to dissolve many substances critical for biochemical reactions. Reactions such as hydrolysis, photosynthesis, cellular respiration, enzymatic reactions, and protein folding. It is worth noting that biodiversity on Earth is spectacular. It is estimated that there are over 8.7 million species on our planet, and that is likely an underestimate. Many species thrive without the things that are essential for human life. Some survive without sunlight, or land, or oxygen. Some even survive extreme temperatures. Despite the incredible biodiversity on our planet, all species have one thing in common. They all rely on water and cannot survive without it, just as this verse in the Quran stated. In fact, when scientists look for life on planets outside our solar system, a common method is to look for signs of water, conjecturing that if life on Earth requires water, it is also probably true for some other planets. But is it possible for other chemicals to replace water as a biological solvent? In other words, is it possible for life to exist on other planets without the need for water? Theoretically, liquid methane or liquid ammonia could act as a solvent for biological life. On our planet, they are naturally found as gases. However, temperatures on some moons or planets are cold enough to have these chemicals in liquid form. But practically speaking, planets or moons cold enough for methane or ammonia to be in liquid form would mean that any biological reaction that took place would be extremely slow, which limits the probability and degree to which life could evolve on them. On Earth, all life requires water, and if life exists on other planets, that is probably true there as well. In fact, as of February 2024, over 5,500 exoplanets have been discovered in our Milky Way galaxy. Yet so far, no planets have been confirmed to contain water. Of course, that is not to say we won't eventually find exoplanets that do contain water. A planetary system called Kepler-138, which is 218 light years away, shows promise. Based on the sizes and masses of two planets in that system, they may contain water. However, other observations have yet to verify that finding. This begs the question, where did Earth's water come from if water on planets is so rare? There are four theories. Some scientists believe water was present as ice when Earth formed from dust and gas. The Quran refers to this dust and gas that formed the Earth as the sky when it was smoke, dukhan. According to this theory, when the planet formed, this ice may have become part of it. Over time, as the atmosphere formed, creating higher atmospheric pressure, the boiling point of water would have risen and the ice would have melted to form oceans. A second similar theory is that Earth's water comes from within the Earth itself, a process known as outgassing. Volcanic activity would have released water vapor into the atmosphere, condensing and falling as rain to fill the oceans. A third theory is that water was delivered to Earth by comets and asteroids known to contain water, or ice. When they collided with the Earth, the ice would have melted and added to the planet's water supply. Recent research leans more towards asteroids because the water in some asteroids has a similar ratio of hydrogen isotope deuterium compared to the water on the surface of the Earth. The concentration of deuterium in comets is much higher. Finally, it is possible that Earth's water came from a combination of these sources. All of these theories have one thing in common. Whether water formed on the surface from the ice as the planet grew in size, formed under the surface and was outgassed by volcanoes, or arrived on asteroids, Earth's first water came from the sky. The Quran says, "And we let loose the atmospheric winds to fertilize plants, and we sent down water from the skies, so you could drink when you had no other supply." The point of this post is that on Earth, water is necessary for life, confirmed both by science and the Quran. The source of water on Earth, according to all scientific theories, is the sky, which is exactly what the Quran says. SubhanAllah. If you enjoyed this video, please like, subscribe, and share.